Exercise 10B, second bit, first question. Second bit, first question. 5 coins are tossed. 5 coins are tossed. 320 times. 320 times. 5 coins are tossed 320 times. Find the frequencies. Find the frequencies. Find the frequencies of the distribution of the number of heads and tabulate the result. Okay, so simple thing. So 5 coins are tossed 320 times. If 5 coins are tossed, what are the possible results? So 0 heads, 1 head, 2 head, 3 head, 4 head, 5 heads. So these are the 5 heads. So we are counting. If 5 coins are tossed, how many times head will appear? If we count like this, so this experiment is conducted for 320 times. Out of 320 times, how many times 0 heads came? How many times 1 head came? How many times 2? How many times 5? Like this. Okay, we need frequency distribution table. So also probability distribution table, frequency distribution table. So with the help of probability distribution table. Now solution. So 5 coins are tossed 320 times. If 5 coins are tossed 320 times, so 320 I am keeping capital N. So n equal to 5 coins. Okay. So P equal to 1 by 2 head. Probability of failure is also. I am taking capital N equal to 320. Capital N equal to 320. So this 320 times again we are conducting this experiment. Now P of x equal to x. N Cx e power x q power n minus x. M equal to 5 C x P 1 by 2 whole power x q 1 by 2 whole power 5 minus x. So 5 C x 1 by 2 whole power x plus n minus 5 minus x. X cancel. 5 C x 1 by 2 whole power 5. Now so we need P of x equal to 1. X equal to 0 started with 5 C 0 1 by 2 whole power 5. 5 C naught value 1. C naught 1. 1 by 32 equal to 1 by 32. So x equal to 0. P of x equal to 1. 5 C 1 into 1 by 2 whole power 5 equal to 5 C 1 value 5 into 1 by 2 power 5 32 5 by 32. Next P of x equal to 2. P of x equal to 5 C 2 1 by 2 whole power 5. So 5 C 2 I will write 5 into 4 by 1 into 2. 2 into 1 2 into 2. 5 into 2 10 into 1 by 32 equal to 10 by 32. Next P of x equal to 3. 5 C 3 1 by 2 whole power 5. 5 C 3 5 into 4 into 3 by 1 into 2 into 3 3 cancel. 5 into 2 10. 10 into 1 by 32 equal to again 10 by 32. Next P of x equal to 4. 5 C 4 1 by 2 whole power 5. 5 C 4 which is equal to 5 C 5 minus 4. 5 C 1. 5 C 1 equal to 5. 5 into 1 by 32 equal to 5 by 32. Next P of x equal to 5. 5 C 5 1 by 2 whole power 5. So 5 C 5 value 1 by 32 1 by 32. Now I want to write a frequency distribution table. So x equal to x, P of x equal to x. 0 1 2 3 4 5 probabilities. 0 probability 1 by 32, 5 by 32, 10 by 32, 10 by 32, 5 by 32, 1 by 32. So these are the probabilities. If we add all these probabilities, we will get a 1. Now, so what we need is frequency distribution. So tabulate the number of bits. P of x equal to x. Frequencies. So frequencies means we are conducting this experiment 320 times. All we multiply with 320. 0, 1, 2, 3, 4, 5. Denominator 320, 32. Numerator 320, 32 cancel 10. Numerator multiplied with 10. 10. 5 into 10, 50. 10 into 100. 10 into 10, 100. 10 into 10, 100. 5 into 10, 50. 1 into 10, 10. This is the required frequency distribution table of this experiment. Okay, this is the required result. Next concept, Poisson distribution. So up to till now we discussed binomial distribution. So binomial distribution we discussed according to the distribution of binomial distribution formula. We distributed all the properties. Here we are distributing according to the Poisson's law. What is Poisson distribution? Okay, so P of x equal to x equal to e power minus lambda into lambda power x by x factorial. This is the Poisson distribution formula. So this is the Poisson distribution. This formula, according to this formula, Poisson distribution will follow. So and x equal to x, P of x equal to x. So 0, if we are taking 0, 0, 0, e power minus lambda. This is 1, this is also 1. 1, e power minus lambda into lambda power 1 by 1 factorial. 2, e power minus lambda, lambda square by 2 factorial. 3, e power minus lambda, lambda cube by 3 factorial. Up to so on. So in binomial distribution we know what is the last one, but in the Poisson distribution we don't know what is the last value. Okay, so this is the distribution. This kind of distribution is called Poisson distribution. Okay, now properties. So first one, in the binomial distribution, n, p, q are the binomial variables. Here lambda is the only variable. So lambda is the only Poisson variables. Okay, in the binomial distribution n, p, q. So in the binomial distribution each tribe is independent. Here also each tribe is independent. Each tribe is independent. It doesn't depend upon the previous. So next, third one, number of tribes are sufficiently large. Number of tribes are sufficiently large or infinitely many. Okay, what is sufficiently large? In the example of binomial theorem, let us consider. So rain falls out of 30 days for some days. This is binomial distribution. For example, out of 30 days, how many number of times rain may fall? How many number of days rain may fall? Okay, if we are counting the number of days, 0 days may fall, 1 day, 2 days, 3 days, maximum number of days, 30 days it may fall. But if I asked number of times, how many times rain will fall in 30 days, we can't decide. So it may fall 100 times, 1000 times also rain may fall. If the number of days follow binomial distribution, number of times it follow Poisson distribution. Okay, one more example. If we are taking certain 1 week, how many accidents? So it may, how many number of days, how many days accidents may occur. So 0 days, 1 day, 2 days, up to 7 days accidents may occur. But number of times accidents, number of accidents if we are taking it, it is not maximum of 7. It may be maximum of so many. So number of accidents is following Poisson distribution, and number of days follow binomial distribution. Okay, so number of trials are sufficiently large. And next one, so mean and variance. Mean is equal to lambda, variance is also equal to lambda. Mean and variance of a binomial Poisson distributions is also equal to lambda. Mean is equal to variance in Poisson distribution, but mean equal to NP, variance is equal to NPQ in a binomial distribution. But here it will be different. Okay, now we will discuss some problems. Okay. First we take the question. In a city, 10 accidents take 10 accidents. In a city, 10 accidents take place. In a span of 50 days. In a span of 50 days. Assuming that the number of accidents follow the Poisson distribution. Find the probability that there will be 3 or more accidents in a day. Okay. Now I want to find a solution. In a city, 10 accidents in a span of 50 days. So lambda equal to 10 accidents out of 50 days equal to 1 by 5. So we need to calculate for 1 day simply. Why I am taking denominator 50, and we need to calculate for 1 day. So that's why 10 by 50 is equal to 1 by 5. Okay, now we need 3 or more accidents. Probability of 3 or more accidents is P of x greater than or equal to 3. We need to find P of x greater than or equal to 3. Okay, now P of x equal to x formula, e power minus lambda power x by x factorial. This is the formula. E power minus lambda power x by x factorial. What is e power minus lambda? E power minus 1 by 5 lambda 1 by 5 whole power x by x factorial. We need to find P of x greater than or equal to 3. Means x equal to 3, 4, 5, 6 up to so on. We don't know what is the last one, so up to infinity. Okay, so we are adding all these, so that's why I am taking sigma e power minus 1 by 5 whole power x by x factorial, x value 3 to infinity. So this is the required result. Okay, next question. Third question is the number of persons joining A cinema ticket counter. A cinema ticket counter. A cinema ticket counter in a minute has Poisson distribution with parameter Poisson distribution with parameter 6. Find the probability that first one, no one joins in a queue. No one joins in a queue in particular minute. Second, no one joins in a queue in a particular minute. Second, two or more persons join. In a minute. Okay. So, if we are joining for ticket in a line, in a theater or somewhere else. Okay, if we are joining for cinema ticket for in a line. Okay, in a particular minute, so the number of persons may join is 6. So lambda equal to 6. Parameter 6 is nothing but lambda equal to 6. So in a particular minute, we don't know how many members join. It may join 0, it may join so many. So it follows Poisson distribution, but simple thing is given that so we are not thinking too much in the Poisson distribution formula. Simply in the question itself it is given the word Poisson. Here also given Poisson. So Poisson lambda equal to 6. So it should be mentioned Poisson. If it is not mentioned, you simply take binamial. So lambda equal to 6. So first one, P of x equal to 6. X formula e power minus lambda power x by x factorial, which is equal to e power minus 6 power x by x factorial. First one, no one joins Q. No one joins means P of x equal to 0. So e power minus 6 power 0 by 0 factorial. 6 power 0 1, 0 factorial 1, overall e power minus 6. Next, second, 2 or more join in Q in particular minutes. So if we are taking like this, P of x greater than or equal to 2, e power minus 6 power x by x factorial. So sigma x value is 2 to infinity. How many join we don't know. Let us consider that. Okay. Next, example 6th. So sixth example is a Poisson variable satisfies. A Poisson variable satisfies P of x equal to 1 equal to P of x equal to 2. P of x equal to 1 equal to P of x equal to 2. Find P of x equal to 5. We need to find P of x equal to 5. So this is very important question. So first solution. I want to write the formula P of x equal to x. Formula e power minus lambda power x by x factorial. E power minus lambda power x by x factorial. So P of x equal to 1 equal to e power minus lambda lambda power 1 by 1 factorial. P of x equal to 2 e power minus lambda lambda square by 2 factorial. P of x equal to 1 equal to P of x equal to 2. So this is P of x equal to 1 e power minus lambda lambda power 1 by 1 factorial equal to e power minus lambda lambda square by 2 factorial. E power minus lambda cancel, lambda by 1 equal to lambda square by 2. So one of the lambda cancel implies lambda value 2. So for the same question sometimes it is given mean is equal to lambda equal to 2. If the question is asked mean value 2. If it is given variance lambda, that is also which is equal to 2. So here for this question this is not important, not required, but if the question is given like that mean, so mean value to variance value is also equal to 2. Now P of x equal to 5. What is this? This one x equal to 5 e power minus 2. Next 2 power 5 by 5 factorial. E power minus 2 into 2 power 5 32 by 5 factorial. 1 into 2 into 3 into 4 into 5 120. So 8 into 4 8 into 15 4 by 15 is 12. This is the required result. Okay, now fourth question. Example 4. Example 4. In a book of 450 pages, in a book of 450 pages, in a book of 450 pages, 400 are typographical errors. 400 are typographical errors. Typographical errors. Assuming that the number of errors per page, assuming that the number of errors per page follow Poisson law. Find the probability that a random sample of 5 pages will not contain no typographical error. Okay. So solution. So out of 450 pages, so 4 typographical errors. How many pages? In a book of 450 pages, a book contains 450 pages. So how many errors? 400 pages. 400 errors. So 4 out of 450 pages, 400 errors. According to one page, I want to calculate. So lambda equal to 400 by 450 is equal to 5 by 9. 5 by 9. What is 5 by 9? Not 5 by 9. 8 by 9. 50 into 8, 50 into 9. Lambda value 8 by 9. This is calculated for single page. Single page, the typographical error parameter 8 by 9. Okay. Now I am applying the formula P of x equal to x. E power minus lambda power x by x factorial. We need no typographical error. So P of x equal to 0 equal to e power minus 8 by 9 into lambda power 8 by 9 power 0 by 0 factorial e power minus 8 by 9. This is 1, this is 1. So this is for one page. So if we are calculated for 5 pages, probability equal to e power minus 8 by 9 whole power 5 equal to e power minus 40 by 9. So this is the required result. So for one page e power minus 8 by 9, for 5 pages no typographical error into whole power 5. So this is e power minus 40 by 9. Okay, next question. Fifth, deficiency of red cells in a blood cell is determined by examining a specimen of blood under a microscope. Suppose a small fixed value contains on an average of 20 red cells for normal persons using Poisson distribution. Find the probability that a specimen of blood taken from a normal person contain less than 15 red cells. Okay. First, so deficiency of red cells in a blood cell determined by examining a specimen of blood under microscope. Okay. Later, suppose a small fixed value contain an average of 20 red cells. So solution 20 average 20 lambda equal to 20. So a normal person using Poisson distribution. So here it is mentioned Poisson distribution. The probability specimen blood group taken normal person less than 15 red cells. Okay. So lambda equal to 20. Now P of x equal to x equal to e power minus lambda power x by x factorial e power minus 20 power x by x factorial. So we need less than 15. P of x less than 15 sigma e power minus 20 power x by x factorial. So up to 15 x equal to 0 to 50. So this is the required probability. So less than 15 means we need to take 14 up to 14. So x equal to 0 to 14 e power minus 20 power x by x factorial. So this is the required result. So if we observe all the problems in Poisson distribution, word containing Poisson. So in this is the word Poisson. Here this is the word Poisson. So this is the word Poisson. Here also Poisson word. Here also Poisson distribution. It is an indication to do the problem with the help of Poisson distribution. If the word Poisson is not mentioned, we need to apply binomial distribution. Okay, this is